All right, hello everybody. Welcome to our first video during this session. Today we're going to be talking about the Pythagorean Theorem. Pythagorean Theorem. Okay. So this will look very similar to what we've done in class before. Feel free to pause the video, rewind, fast forward, anything you need to do. I guess so. Getting started on this, there are a few things that I want to review first. So, for example, some exponent stuff. So back in Unit 1, we talked about our exponents. We just want to see if we remember how to do some of this stuff. So, for example, if we showed you 4 squared, basically that means 4 times 4, or 2 of those 4s. So 4 times 4, and if you know it off the top of your head or use your calculator, you get 16. Okay, so not so bad there. But what happens once we get to fractions? Okay, if we have a fraction outside, or a fraction inside and exponent outside, remember that exponent gets applied to both pieces. So we really have 2 squared over 3 squared, or in the end, 4 over 9. All right. A couple more of these. So let's see. Some special cases here. If we have the square root of 6, and then we square the whole thing, you hear the wording on that. We have square root and square. They're opposites of each other. So that exponent 2 and that square root symbol will cancel each other out, leaving us with just 6. All right. And finally, let's say we had 5 square root 3, whole thing squared. Again, just like before, we've got to apply this exponent to every piece inside. So it's getting applied to the 5 and to the 3. All right, so 5 squared is 25. And remember, when you square a square root, this 2 and this x, or that square root symbol, cancel each other out. So you're left with a 3, and they're connected by multiplication. So 25 times a 3 comes out to a 75. So actually, let's see one more of those. Let's take 10 square root 6 and then square the whole thing. So again, exponent gets applied to everything. So 10 squared, 100. To this, gets canceled out. So times by a 6, and 100 times 6 gives me 600. All right. So now let's actually get back into what we're doing today. We're going to use that a little bit later on. So we're talking about Pythagorean Theorem. All right. So a couple notes to make here. Pythagorean Theorem can only be used on right triangles. Okay, it can only be used on right triangles. And that means these are triangles that have a 90-degree angle on them. What it's actually used for, and hopefully this isn't something too new to you, if they give us 2 sides of a right triangle, we can use this Pythagorean theorem to find the third. The third side. So I'm writing kind of fast because I realize you guys aren't going to write these notes down anyway, so you just use the video as your notes. So if it's something hard to read, just listen to my words rather than reading it. Okay? So picture-wise, remember this can only apply to right triangles. So we want to talk about these right triangles. And again, a right triangle has a 90-degree angle in it. Okay. One of these sides is the most important side. All right, the most important one is the side that is the longest, the one that is across from the right angle, and that is called the hypotenuse. All right, that one is the most important side. The other two sides, we can call those legs. They are the two shorter sides. All right. So, in the case of the actual Pythagorean theorem, or the rule that we're going to use today, the rule itself is a squared plus b squared equals c squared. So I'll make a note of that. And if we match it up, both a and b, these are the legs. You can put either number in either place. A and B don't really matter, but C has to always be the hypotenuse. It's the most important side, it's the biggest side, has to be C. Alright, so again, we use this to find the missing side of a right triangle. So let's get to our first example. So example number 1. Have to give us a right triangle. Right angle. Okay. So they're going to give us a 15, a 20, and then a question mark over here. The question is going to be, what is the missing side? Or find the missing side. First thing you want to do is label everything. And remember, we're using Pythagorean Theorem. If we're given two sides, we can find the third one. So a squared plus b squared equals c squared. And let's figure out which one's which. C is always the most important side, and that's the hypotenuse, the longest one, the one across from the 90-degree angle. So the question mark that we're trying to find is C. And remember, A and B doesn't really matter which one you call it. So I'll go ahead and call it 20A and 15B. So I have A, I have B, I need to find out what C is. But just looking at the numbers, we have a 15, we have a 20, and this C is the longest side, so it should be something bigger than 20. Let's check that again later on. So let's take everything we have and plug it in. So I'm going to put blanks for everything that I'm trying to plug in. Alright. So instead of A, we have A labeled as 20. So I'm going to put a 20 right there. Instead of B, I have that labeled as 15. I'll put 15 there. C, we put a blank, but we don't know what it is, so we can just leave it as C. That's what we're trying to find out. We're going to solve for C. And from here, it's all calculator work. So we take this, 20 squared. My calculator tells me that's going to be 400. Plus 15 squared, 225. Equals C squared, what we're trying to find. And again, just following our steps, 400 plus 225, that gives me a 625 equals C squared. Now just looking at 625, that number is way too big. That's not what our answer is yet. But you'll notice we don't have C by itself yet. We have an exponent 2. The opposite of an exponent 2 is to square root. So that symbol cancels this one. But what we do to one side, we do to the other. So in the end, C is going to equal, and then we use our calculator, take the square root of 625. Answer comes out to 25. So we just check it real quick. I put it up here, 25. That makes sense. That is the biggest side, it's the hypotenuse. All right. Let's try another one. So for example, let's give you a right triangle. I can do better. Right triangle. So we want to mark off our right angle. We'll use that one right there. And let's give you some side lengths. Let's call this 6, 10, and then question mark over here. Again, if we're given two sides of a triangle and we're trying to find the third, and it's a right triangle, we can use Pythagorean Theorem. Let's match it up. So between the 6, the question mark, and the 10, C is the most important side. So C is the hypotenuse. In this case, 10 is C. A and B really doesn't matter where you put it. I'll call A 6 and B the one that we're missing. So let's plug in again. A, we labeled that as 6. B, don't know yet. C, 10. 6 squared is 36. B squared is just B squared, and then 10 squared, 100. Now you notice this time we're not solving for C. So B is kind of left over here with another number. We've got to isolate it. We've got to get it by itself. So the first thing we need to move is actually the 36, but moving it to the other side of the equal sign, we have to subtract. So now B squared equals 100 minus 36 is a 64. And again, we're left at the point where B is not by itself yet. We got a square root to get rid of that exponent 2. And doing that to both sides, square root of 64 is an 8. And let's just check it real quick up here. If B is 8, that looks like that makes sense because the biggest side should be this 10, the hypotenuse. All right. Let's go ahead and try one more here. Let me see a good example. All right. So, again, always have to be right triangles. So that's that. Let's call this 4. Let's call this square root of 101. And then my question mark or my X down there at the bottom. All right. A squared plus B squared equals C squared. So again, pause the video at any time if you want to try out the problem before I do. Write it down in notebooks wherever you got some space. So again, C is the most important one. Of these choices, C is the square root of 101. A and B doesn't really matter. I'll go A is 4, B is my question mark, C is 101. So we got 4 squared plus B squared equals, square root of 101, but the whole thing has to be squared. All right, so let's see, I've got 16 plus B squared equals, and again, remember from our review earlier, these cancel each other out, so we get 101 minus 16 on both sides. So B squared equals, and I go over to my calculator, 101 minus 16, 85. Remember, last step, square root stuff. B equals. You've got a couple choices here. As of right now, I'm okay if you leave it as square root 85. That doesn't make much sense to us if we're trying to put it back onto the picture, though. We want to check. So, real simple thing. You put this on your calculator, take the square root of 85, and you get about 9.2. That looks like it fits pretty well on our triangle. All right.